will serve as a recap on basic radical skills and then get into multiplying radicals. So here's your basic setup. N is the index. The symbol itself is called a radical. The number underneath the radical is called the radicand with an N. If no index is given, then you assume that the index is a 2, which means that you're taking the square root. And you're only looking for the principal or positive root whenever you're taking a perfect square. So if no symbol is given, then you just want the perfect square. If the problem is presented like this, then you can give both the positive and negative root. But if nothing is indicated in front of the radical symbol, then you only want the positive root. So here I've simplified the first 4 problems for you. 16 is a perfect square. Number 3 is 6 times 17. 289 is 17 squared. 121 is 11 squared. And then multiply by the number that's sitting outside of the radical. 400 is 20 squared. And then multiply that by the 3. I feel like these are old skills, but since we're coming back to this unit, I wanted to start with a little review here. So let's move on. Simplifying non-perfect squares. I'll do a few of these. 32 is 16 times 2. The perfect square is 16. Radical 2 is not a perfect square. So the simplified answer would look like this. The square root of 16 is 4, and you would write it without the radical symbol. Let's look at 180. That is 36 times 5. 36 is the perfect square. 5 is not a perfect square. So to present this in its most simplified form, the square root of 36 is 6 without the radical symbol. So 6 radical 5 would be the simplified version of number 6. And you all are capable of finishing the others on your own. Let's move on and do something new. Let's move to multiplication. So when you're multiplying radicals, here's your basic property. The square root of a times the square root of a is the square root of a squared, or just simply a. So when you have a radical multiplied times itself, it's just simply the radicand, or the number that was underneath the radical. If I have the square root of a times the square root of b, that's the same thing as having one big radical with the product of a times b under the radical. So let's use the 2 basic properties as we look at some of these questions. Number 1, I have a number outside, the 4, so I'm just going to leave it sitting there for just a minute, and I'm going to gather the 2 and the 12 under the same radical. So I'm now going to simplify the square root of 24. So 24 is 4 times 6. The square root of 4 is 2. So you could think of this as the square root of 4 times the square root of 6, which is just going to be 4 because the 4 is sitting out here, times 2, representing the square root of 4, radical 6. So your simplified answer would be 8 radical 6 for number 1. Let's look at number 2 together. Number 2, I've got the negative 5 factor sitting in front of the 10, so I'm just going to write it here and ignore it for a minute until I get to the end. And then underneath my radical, I'm going to multiply 200 times 10, or 20 times 10 rather. That's going to give me 200. I'm looking for the largest perfect square factor of 200. That's going to be 100 times 2. So I have the negative 5 that was sitting out here, the square root of 100, which is the perfect square, and the square root of 2. The square root of 100 is 10, and I would multiply that by the negative 5 that was sitting in front, and then radical 2 remains as radical 2. So my simplified answer is going to be negative 50 radical 2. That's my completely simplified answer for a problem like number 2. Let's move on and look at a few more. A problem like number 3. I've got a factor of negative 3 sitting here, so I'll just copy it to the side. And then I have radical 3 times radical 3. Notice the same radical times itself. So I've got the factor of negative 3 that was sitting out there times the square root of 9, which is the perfect square. So this is really just negative 3 times positive 3, and my simplified answer would be negative 9. Let's look at number 4. So under one radical, I'll multiply 10 times 4. So I'm now looking for, well, 4 was the perfect square, but I'm looking for the largest perfect square factor of 40. So that's going to be 4 times 10, which is what I just started with. Square root of 4 is 2, so 2 radical 10 would be the simplified answer for a problem like number 4. And I really did not need to go through all the properties to simplify that, but I did anyway just to keep the process going so that you have skills to work with when the problem is less straightforward. And let's see, let's look at a few more on the video, and then I think you can probably do some of these on your own. Let's look at number 8. So here I'm going to have 3 times 6 under the same radical. Largest perfect square factor is going to be 9. So the simplified radical answer for this product would be 3 radical 2. 9 is the perfect square, radical 2 is not. The square root of 9 is 3, so I would write the 3 without the radical, but radical 2 remains underneath. And then 10 times 6, so that's going to give me 60. 60 is 4 times 15. 4 is the perfect square. Square root of 4 times the square root of 15. So that simplified answer, the square root of 4 is 2 without the radical symbol. So 2 radical 15 would be my simplified answer for number 10. And I feel like that is enough examples for you to get through the rest of the problems on your own.